We've learned about the different types of energy and how energy converts from one form to another. Now we need to talk about how heat is transferred. So we're going to talk about the three methods of heat transfer, which are conduction, convection, and radiation. First thing we need to do is identify what heat is. So heat is the movement of what we call thermal energy, which we talked about a couple of days ago, from one substance at a higher temperature to another substance at a lower temperature. So heat is always going to move from an area where it's hotter to an area where it's colder. So if you've ever noticed, when it's hot in the classroom, I'll open the door of the classroom because the hallway is cooler. So some of that hot air will move out into the hallway. And the hope is that that hot air will move out and the room will start to cool down. So let's look at heat versus temperature. A lot of people mix this up and they think that heat and temperature are the same thing. Well, heat is the actual energy that is provided there. So temperature is going to be the measure of the average kinetic energy of the particles in a substance. So we're looking at heat as the energy, but temperature as the measurement of that heat. So overall, heat is not the same thing as temperature. Always remember that. Heat and temperature are different. Heat is the energy. Temperature is the measure of that energy. Let's look at heat transfer quickly. Heat always moves from something that's warmer to something that's cooler. So heat is going to move out of the hot room into the cool hallway. And the thought is that that room will cool down. Hot objects in a cooler room are going to cool down to room temperature. They always want to become what the dominant temperature is. So if it's hot in the room, all the objects in the room that are cooler will start to cool down or start to become the same temperature as the room. Cold objects in a warmer room will heat up to that room temperature. So always remember that. Heat always moves from a warmer place to a cooler place. Hot objects in a cooler room will cool to that particular temperature. And then cold objects in a warmer room will heat to that room temperature. So that brings us to the methods of heat transfer. Excuse me. They are conduction, convection, and radiation. So we're going to talk about each of these individually. So we're first going to look at conduction, then convection, then radiation. Conduction. It's going to be the heat transfer that is flowing of heat from a high temperature object to a lower temperature object. So we're always going to move from high to low. And one of the things that we have to remember is that it happens in solids and that those solid materials have to touch the heat source. So it's by direct contact, and we're going to look at some of those in just a second. So if we look at conduction by cooking, if the pan touches the burner, that's direct contact. It's directly contacting and touching the heat source. So when you heat up, let's say we heated up a metal strip, those particles would start to bounce up and down, and we know that anytime we heat up something, the particles start to move quickly. Now when we look at temperature of this would measure how quickly those particles are moving. So heat is the actual energy, temperature is the measure of that energy, and when we heat up solid objects that are touching the heat source, we're going to call this conduction. So when we take a look at metals, metals are very, very good conductors of radiation, energy, heat, any of those. They're going to be very good conductors. And that is because the outer electrons of metals drift and are free to move. So they can move quickly. And when metal is heated, those electrons are going to gain kinetic energy. and that kinetic energy is going to move through that metal. So in the activity we did before this, if you notice, there were some objects that did not conduct electricity, and they did not conduct any type of energy that we were trying to conduct at the time. And so those materials didn't make the light bulb come on. Those are called insulators. Insulators such as wood and plastic, they don't have those electrons, so they don't conduct heat as well as those metals. Convection. Okay, convection is a little bit different. Convection is going to be the transfer of heat through a fluid. Most people think of fluids as liquids, but fluids are actually, in this case, going to include gases as well. And if you notice down here, you're going to create a current. Okay, so if we are heating up something that is liquid or something that is a gas, such as air, that is the process of convection, and it's going to create this current. So if you've always heard heat rises, that is absolutely true, because if you've noticed, when it becomes hot in the building, because we are upstairs, it is hotter upstairs than it is downstairs, and that is because heat rises. Once it rises, it tends to cool down at the top, or at the top of the building. That heat then drops and it rises again, so it creates this current. So cooler water is going to sink. In this case, it's going to heat up at the bottom by the heat source, and then it's going to rise, and that's called a convection current. So let's look at what happens to the particles of the liquid when you heat them. When you heat them up, we automatically know that they're going to start to separate and become farther apart. So the more you heat a liquid, that liquid's going to turn to a gas, which we learned earlier in the matter unit. So the particles become spread out, they're going to become less dense, and when they become less dense, they're going to sink. And so we continue that process over and over again. So cooler water sinks, it's heated up, that hot water rises, and we create this convection current. So water movement is going to move exactly like the air that I described earlier is going to move in a circular current. Last but not least is radiation. Radiation is going to be a method of energy transfer that does not need a medium, so it doesn't need a solid, a liquid, or a gas. The sun is the best example of radiation. It's how the earth is heated. There are no particles in between the sun and earth, so there's no solid, liquid, and gas, okay, until you start to get into the atmosphere of earth. So it can't travel by conduction or convection, so it has to travel by way of radiation, and radiation is going to be the only one of the three that doesn't need a solid, liquid, or gas to transfer through. So when we look at radiation, it is the transfer of energy by these electromagnetic waves. Later on, we're going to talk about the different types of electromagnetic radiation and what they do, especially when we start to talk about waves. So examples of radiation would be the sun, fire, so if I were to light a fire, that would put off radiation, and a light bulb, so visible light, the light that's in this room, that's going to be an example of radiation.